Peter Braffett is the general manager at Gemico Marine Accessories, well known across the industry as an expert in transducer selection and placement, as well as everything NMEA. His passion for cutting-edge electronics and saltwater fishing leads his relentless drive to rediscover the latest advancements in the marine electronics technology. Previous to the past 10 years at Gemico, Braffett was the business manager development for Airmar Technology Corporation. He's worked with many boat manufacturers to satisfactorily integrate transducer installations into their assembly process. With nearly 20 years in the industry, he's well versed in the latest marine technology and boat products from bow to stern. And the title of his presentation is NMEA 2000 Smart Yacht Technology. Please welcome Peter Braffett.
Thank you. Good morning. How many of you in the room have heard of NMEA 2000? Excellent. Well, we're going to cover basically not the technical aspects of it, but the reasons that you might want to consider it. One of the biggest things with NMEA 2000 is why should you consider installing it? A lot of the refits, NMEA 2000 becomes a big part of that because the customers doing a refit want to bring modern technology into their boats. And so today we're going to cover why would you want to consider installing it, the basic components of an NMEA 2000 system, what it involves, what systems can be monitored with it, the most common parameters that are monitored. There's some that are at the top of the list, and we're going to cover those, and how can this data be displayed. So starting with why you'd want to install NMEA 2000, the first thing that I like about it is the system follows an NMEA installation standard, so it can be troubleshot and serviced by any certified installer. In a lot of refits, or even in new builds, customers get talked into doing these proprietary systems that are a one-off, where they hire an engineer or software engineer to build a custom system for that particular vessel. The challenge there is when the customer decides down the road that they want to upgrade that system, they've got to bring that same company back in, or if they're off in Europe and they're traveling and they need service on the vessel, it's a proprietary system. They have the expense of flying that same engineer out there to fix something or make a change. So NMEA 2000 is a non-proprietary system. It follows a protocol, but it's a standard that many companies follow. So future upgrades, expansions, very simple, can be performed by any certified installer anywhere in the world. It's a standard, and it's a worldwide standard. So again, any installer that is NMEA certified can get on the boat, figure out the system that's there, and add to it or troubleshoot it. NMEA 2000 systems offer a significant weight savings compared to traditional copper wiring. So during a refit, that can become a really good asset, is to pull out all that old wiring that wasn't labeled well, and a lot of those systems can be converted using an NMEA 2000 network. Weight savings is a real big thing in these boats, and this image shows where this particular wire run might service 5, 6, 7, 8 different sensors. That single NMEA 2000 cable can handle that communication and power transfer. So there can be a pretty significant savings if a full system's integrated. So why install it? NMEA 2000 information is a common format, and it can be displayed uniformly by any compatible device on the network. Again, as I mentioned, it's non-proprietary. If you add a Simrad display or a Garmin display or a Furuno display, they can all take in and understand that NMEA 2000 information. You can mix displays from different manufacturers. If you like a certain style of a brand and you want, in all the salon and in all the main staterooms, you want small displays, and then up on the bridge you want a different brand of displays. They can all be mixed and matched because, again, it's a common protocol. There are hundreds of vessel parameters now available to monitor over NMEA 2000. The list of what can't be monitored is very, very short, and that's growing daily. I mean, it seems like every day I turn around, there's a new manufacturer that's come up with a new idea or some parameter to monitor on that vessel. So pulling data from many sensors and combining that information using various methods can produce synthesized data. And that's one of the neatest things about it. The more information, it's kind of like the internet on the vessel. The more information that's in that data pool, all the devices on that network can pull from that data pool simultaneously. So you can imagine some of the possibilities where true fuel burn can be calculated using data from the fuel flow sensors, fuel tank input, a lot of different variables, engine RPM, pressures, and all that. So synthesized data means, basically taking all these different parameters, pulling that information together and giving you very precise calculations and predictions based on that information pool. There's a convenience factor. From the end user standpoint, they might not necessarily care about all that in the background. All they want to know is that they want to be able to turn lights on and off from their smartphone before they board the boat, or turn a freezer or cooler, or turn the air conditioning on or up before they get to that vessel. NMEA 2000 can give you that protocol that allows you to do that. And as I mentioned early on, it's non-proprietary. So there's many, many companies that contribute to products and software and services that run over an NMEA 2000 network or extract data from an NMEA 2000 network. So, this is a really widespread possibility on, running new apps. We're seeing apps come out daily. We're seeing software come out quite often that allows you to do different things. NMEA 2000 can contribute to safer boating. Information's easily adapted to a specific task. One of the examples we're seeing a lot of is small sailboats with a single diesel, where they didn't necessarily have engine data, displayed on a helm anywhere. They can now have that engine data displayed on an iPad or an iPhone or some sort of an Android device. So they're more aware of the engine and what it's doing, and they're not using it all the time like a powerboat would. So it's a great way to make use of that NMEA 2000 network. Safer boating. Crews are more informed. Situational awareness is improved. Things like refueling. I don't know how many times I've been on a large sport fishing vessel, and they've got two people fueling up the boat. One of them standing there with the fuel inlet. The other one's looking at a sight glass, and he runs off to do something else, and all of a sudden there's a spill. Well, the nice thing is that the crew, with NMEA 2000, as I mentioned, you have this data pool. All the people on board can have a wireless device, the cell phone that they're carrying anyway, and that data is available to them. So as they're fueling, they can stand right at that point of fuel and monitor it. Temperatures or anything that they want to see on that vessel can be seen on a smart device of any sort. Off-vessel monitoring, this is one that people don't consider. It's not only a data pool on that vessel, but with internet access, which is obviously very common when the boat's at dock, that data can be sent to somebody off the vessel. For instance, in this case, a dockmaster can receive a high water alert preventing a disaster. The owner is 3,000 miles away, and the dockmaster gets an alert that there's water in compartment 1 through 4. They can get to that vessel and fix the problem before it really becomes an issue. Otherwise, the owner gets there next time and the boat's underwater. One of the other, again, getting data off the boat, putting it out on the internet, allows off-vessel diagnostics. So, the technician that installed this system, the owner has a question, the captain has a question on something that's running, that data can be viewed from a distance, and potentially diagnostics can be done. I know some of the engine manufacturers either have systems or are considering systems where they can do diagnostics remotely. Fleet monitoring. One of the common opportunities with NMEA 2000 is to a company that owns a lot of vessels, especially in the commercial segment, but even a charter group or a rental can track that fleet from anywhere in the world. They can see where those vessels are. It can send GPS data. Some of them are using cellular. Some of them are using Wi-Fi at the dock if it's a short-run vessel. But the point is that those vessels can be monitored from anywhere in the world. Rental fleet and charter owners, as I mentioned, it's pretty common. They can see where the vessels are being used. There's tracking using GPS. There's ways to get the tracks and see exactly where that vessel's been run. So what's involved in an NMEA 2000 system? There's basically two components. The network consists of a wiring system, and it's a standard. So there's a very easy set of parameters to follow. And then there's hardware components that also follow that same NMEA 2000 protocol. So network components, we won't get into the nitty-gritty of exactly hows and whys, but it's real simple. There's power, there's T-connectors, which allow you to connect devices into. There's a termination resistor at each end of the network, and everything connects between those two terminators with backbone and drop cables. Now, there's some more sophisticated calculations that go into this regarding power and voltage drop and stuff like that, but essentially, the protocol is a very easy one to follow as far as networking. It's very basic once you understand the hardware part, the network part of it. And again, voltage calculations are probably the most challenging up there because a lot of the devices draw power from the network. Now, from an installation standpoint, that saves a lot of time because a small display, you're not running power and data to it. You're simply plugging it into an available T, and now you've got it on that network. So this is just a quick installation. As you can see, there's a, let me see if I can find the pointer. So there's a termination resistor at either end of the network, and essentially the network becomes just one loop, and then drop cables go out to each NMEA 2000 certified product. So you can add on as many products on the network as you want as long as there's sufficient power available. And by the way, if there's any questions along the way, you see a slide that triggers something, feel free to ask. Sometimes it's easier than trying to remember it at the end. So the second part of NMEA 2000, and of course the more fun part of it, is hardware components. There's, as I mentioned, just a myriad of different options available for you as far as what can be monitored. And this is just an indication. This is a Maritron image showing, just some of the potential, all of the tanks in the vessel, wind, GPS, vessel monitoring. I mean, the list is really endless. So as far as some of the categories, temperatures, pressures, vacuum, fluid levels, I mean, you can read the list. Data logging is one that's becoming very popular for charter vessels and also commercial, where they can actually log data. I know of a tug company up in our home territory in the Charleston area, where they have had some problems with their captains, pushing the boats a little too hard. They're monitoring all the data on these vessels and they're logging it at all times. That would be very useful as in a charter situation as well, a rental vessel or something like that. Wind and weather is very popular. Environmental, depth, speed, and temp information is very popular as well. So the top 5 categories that we see being used for NMEA 2000 monitoring are navigation, weather, and environment. And by that, almost every single OEM that produces a multifunction display these days, an autopilot or anything, will communicate over NMEA 2000. GPS is standard that way now, wind, direction, tilt indicators. The second most popular is engine and generator data. And the reason for that is a lot of refit market. You may be trying to sell a vessel that's 15 or 20 years old. It's in great condition. The diesels have been updated, but they're not digital, and the customer wants that feel-good of seeing them on their display and having that modern technology. It's actually very easy to modernize a non-digital engine to bring it up to NMEA 2000 standards so that data can be seen. We're going to go into that in a little more detail, but that's a very popular one, as well as generator data. Fuel, oil, water tank, basically any fluid level on the vessel. I think everybody here knows that fluid senders are notoriously inaccurate. So one of the advantages to NMEA 2000 is very, very high accuracy. There's multiple ways that I'll show you in a few minutes to monitor fluid levels, but the result is extremely accurate readings and also, as I mentioned early on, that synthesized data for a display to be able to calculate gallons to empty at your current rate of speed and your heading and be able to tell you where you need to fuel before you get to that next stop or whether you have enough fuel to make it. That's all calculated using a lot of these sensors, but one of the important ones, of course, is fuel levels. AC and DC voltage and amperage monitoring, that's another common one. And AC-DC switching over NMEA 2000, which is really becoming common now. And I have some slides here to kind of support all that. So navigation solutions, as I mentioned, GPS, heading, pitch and roll, basically dynamic motion of the vessel. Almost anything there can be calculated on NMEA 2000, and that data can be shared with all the other sensors on the boat or any other display. One of the nice things about NMEA 2000, if you're familiar with the older standard, which was NMEA 0183, most of the devices needed to have their own source for heading and GPS. So you might have 2 or 3 GPSs, one feeding an autopilot, one of them feeding another brand of display. With NMEA 2000, you can have 1 or 2 data sources on there, so you have some redundancy if you want more than one, but all the displays and all of the material of the systems on the boat can use the same exact data. And everybody knows if you look at 2 GPSs side by side, there's going to be a slight variation in them. But having all the displays be able to look at the same GPS and have a second one for redundancy makes a lot of sense because now all your displays match up, all your alignments match up. Weather monitoring is another one that's pretty popular, especially in the sailing market, but we're seeing some pretty strong adoption in the powerboat market as well. And that's really just situational awareness. When you're pulling up to the dock, it's really nice to know, exactly what the wind speed is and the direction it's coming in, or if you want to see a quick shift in that. Sometimes you can't detect that with curtains up and stuff, so having that wind data on hand is helpful. And as I mentioned, that wind data is going to be the same on every display, because nice thing about NMEA 2000 is everything's using that same data source. So weather monitoring, true and apparent wind speed and direction. This particular unit from Airmar, it has barometric pressure, air temperature, humidity, dew point, heat index, wind chill. These are all in this one single sensor. It's about the size of probably smaller than a soda can. It's very, very compact. Has internal GPS, compass, and heading. And although those typically aren't used for primary navigation, it's nice to have some redundancy on the vessel as well. Meritron offers one as well, wind speed and direction, air temp, barometric pressure, humidity. Both sensors are solid state. As you can see, there's no moving parts to either one of those. So environmental monitoring is popular as well, and by that I say depth, speed, water temperature. Almost every vessel out there is going to have a combination of these on them. There's a lot of different mounting styles. Temperature monitoring is very popular as well. I can't even begin to talk about the list of what people monitor with. It's amazing to us. We'll get calls all the time. They wanted to monitor this and they want to monitor that. And we've had them where they're monitoring individual temperature of every stateroom on the vessel. I mean, there's no end to it. There's ambient air temp sensors, immersion probes available for fluids, ring terminals for surface temperatures, exhaust gas. I mean, the list goes on and on. So sport fishing boats, a lot of times they'll monitor the freezers, and so there's really, like I say, no end to it. Engine monitoring is by far one of the most popular on a refit. A lot of people will end up adding NMEA 2000 just so they can turn an analog diesel into a digital diesel as far as the communication, the monitoring is concerned. There's a lot of different ways to do it. As you can see from here, there's a lot of different methods of it. This particular one here, I'm showing some diesels. There's various methods of getting those onto the NMEA 2000 network. And once they're on that NMEA 2000 network, the data can be pulled to anything from a PC to any brand of display. So you may have multiple points in that vessel with multiple display brands. You might have a PC on there as well. It's very easy to get that diesel data onto the network, and once it's on the network, it can be used by any, any display or any method that you're looking for. And the same with outboards. Outboards are the same way. There's a lot of different ways to get that outboard on there. Some of the outboards, most of the new outboards have NMEA 2000 natively, but if not, there's converters and gateways available. And again, once it's on that common network, the data is available to any type of display. So as I mentioned, one of the most popular ones on a refit is the analog engine. You've got an old diesel with, might be a refit, and it's been rebuilt and it's in great shape, but it has standard gauges on the helm. It's very, very easy to convert that over to NMEA 2000. And most of the time, the original gauges can be retained. Some people want to eliminate the gauges because the dash just isn't conducive to adding these big MFD displays. Other times they want those for backup and just to be able to monitor them as they're going, but they want to be able to have that data available to other things. So some of the converters, like this unit from ActiSense, take the feed right off the back of the gauge. They can tell the difference between when the engine's powered or when the gauges are powered, when they aren't. And they're very accurate, and they convert it over to standard NMEA 2000 sentences that can be read by anything. One converter box typically can convert 2 engines for most parameters. We have had instances where the customers wanted to add boost pressure and transmission temp and many other parameters. In those cases, you'd use 1 box per engine. But in most cases, 1 box will do 2 engines. They're very inexpensive. I think at retail, they're $450, $500 a piece. So you can imagine that the attraction of adding something like that to a vessel. So typically, 1 box will handle 2 tachs, 6 sensor inputs, oil pressure, engine temp, pressure, and voltage sensing. They can also be configured for a lot more engine parameters, or often we'll find that the engine and a genset are selected. You can have one for a genset, but genset monitoring is becoming very popular as well. So J1939 engines, those are a little bit different in that there's standard protocol already. Those of you familiar with J1939, it's a CAN-based protocol. It has different messages at NMEA 2000. There's some pretty standard and easy converters that take those existing J1939 messages, convert it to NMEA 2000, and those again can be read by any NMEA 2000 device. One adapter is required for each engine, and the reason for that is the system needs to identify those engines as a port and a starboard. So there's one per engine, and it also works with J1939 gensets. Outboard engines, as I mentioned early on, there's adapters available, some of them like SmartCraft, for instance. There's a gateway required. Yamaha also has a gateway required. They're using a CAN-based or some sort of a proprietary protocol already, and what that device does is that gateway just converts it over to standard NMEA 2000 messages. Tank level monitoring. This is, I would say, by far one of the most popular categories. I mentioned engines are on refits, but NMEA 2000 tank level monitoring is gaining popularity very quickly because people want to be informed. They want to know when they're out in the middle of the ocean and they can't find a gas station, it's nice to know if you have accurate fuel capacity. So they'll monitor gasoline, diesel, fresh, gray, black, any fluid level you could imagine. Outboards, the older outboards, we have people monitoring the oil tank levels and everything else. So there's different styles: ultrasonic, resistive, pressure, capacitive. So the point is that the NMEA 2000 monitoring can be accomplished in any vessel of any size, a lot of times using existing hardware. So you don't even have to get in that tank and replace an old float sensor. You can convert that standard resistive output to NMEA 2000 and add accuracy to it as well. They're available in standard and European protocols, so 1.5 NPT, British standard outputs, mounting styles. Measure tanks from a few inches to over 10 feet in depth. So there's really a very large range. As I mentioned, there's ways you can measure just about every tank of every size capacity. Most models can be custom calibrated for non-symmetrical tank shapes. And of course, in a boat, everybody understands the V shape. Usually the tanks follow that because they're on the center line. Makes it very difficult to get a linear output. So most of the sensors can be calibrated to overcome that. So ultrasonic can be installed without protruding into the tank. And the reason that's important is on a refit, a lot of times you don't have access. If it's a 36-inch tank, you would need 38 or 40 inches of headroom above it to get a sender down into that tank. And most of the time, those tanks have been put on the boat, and there's furniture, there's flooring, there's stuff over it. So ultrasonic allows you to just kind of slide it into a hole and drop it on the top of the tank, and it uses the same sonar technology that your fish finder uses to look to the bottom of that tank and get pretty accurate readings. They're easily calibrated for odd-shaped, non-symmetrical tanks. There are focus tubes available for planing hulls, and the focus tubes basically are slosh tubes, so they'll hold a small amount of fuel in there, so they're less susceptible to sloshing. Now, when you use a focus tube, of course, you need to have access to the full depth of that tank. If you're putting a 36-inch tank, you need 38 to 40 inches to get that sender down in there. As I mentioned early on, resistive tank level senders, the customer may have fresh WEMA sensors in there or some sort of an analog sensor already in the vessel, and they want to get that data onto NMEA 2000. It's very, very easy to take a standard resistive sensor and convert it to NMEA 2000. Most of those will allow you to maintain the factory gauge as well, so now you have it on the MFD for calculation, and you have that visual that the captain's used to seeing. They can be used with American, European senders. And most of them are programmable for variations as well. Like a standard float sensor is going to be a linear output. But if the tank is nonlinear, you can take that resistive sender and convert that by probably 16 to 24 data points. Depending on the brand of that sender, you can program between 16 and 24 data points. So the lower half of the tank might only hold 25% of the fuel because of the shape of it. You can program that into that sender. So again, very popular to take a resistive sender and convert it over. Pressure transducers are becoming popular on the really big vessels, mostly commercial vessels, but pressure transducers are mounted at the bottom of the tank, and those can be converted to NMEA 2000 as well. And then the other style that's popular, and again, you do need access to get clearance. As you can imagine, you need the same height of that sender above the tank to get it in there, but capacitive tubes. And those are very good. Blackwater, they're good for fuel. They're a little less resistive to sloshing. There's a small tube that the fuel actually goes up inside that sensor, and it's measuring the capacitive, the resistance across the tubes as the fuel's filled, but you can set up to 100 data points on that sensor. So you can see you can get extreme accuracy if you want to take the time. A 100-gallon tank, you can calibrate it at 100 data points and know every single gallon dead on. So, and by the way, the calibration, I should have mentioned that early on. One of the nice things about NMEA 2000 is in almost all cases, calibration data is stored in the sensor. I did mention that quite often, you know, in an early vessel that had NMEA 0183, you'd see variations in that data, and you really didn't know which to look at and which to listen to. One of the things about NMEA 2000 is in almost all cases, the calibration is stored inside the sensor. So every device on the network that uses that does not have to have its own calibration curve. Therefore, that data is consistent across the network. And then I'm spending a lot of time on tanks here, but one of the other things is sender averaging modules. Some of the large vessels had senders at the front and back of the tank just because of changing attitude of the vessel. There's modules available that will take multiple senders, so you can take data from multiple points and it'll average it and give you very accurate readings in dynamic conditions. And we see that a lot in the commercial and the mega yacht market. The other one is a tank volume computer with you can actually put a CAD model, store a CAD model in there. So the sensor can be just on a linear scale, but the CAD model is calculated for the range, so you don't actually have to calibrate 100 points on a sensor. This is very popular with boat builders where they're building a lot of the same, and they'll add that tank volume computer on the network, and it does the calculation for you. And then the last part of tank monitoring is the advantage to it is, as I mentioned early on, fill point. So this is an example of a product made by Offshore Systems. It's very easy to do on a retrofit, but essentially what it's doing is the back of this just has a real simple display that's looking at the tank level, and as the customer's filling, or the captain's filling the vessel, they're seeing real-time data based on those tank level senders right at the point of fill. So, you know, you can even have it set up where, like main tank, day tank, there's transfer switches that will do fuel transfer, and they'll stop automatically at 95% transfer, so you don't have to stand there and watch the little LEDs. So, as I mentioned again and again, the data pool, that huge pool of data that's running on that network.
The automatic shut-off with those transfer switches?
Yes.
Is that class approved?
I believe it is, yes. Offshore Systems is the one here that I'm showing, and most of their products are Lloyd's approved. I'd have to check to be sure of that. And you know, maybe there may be some other versions of this that are class approved, but I'd be pretty sure that they are. Yep. And fuel, I show a freshwater, there's black water transfer. There's all sorts of different gauges available. Most of the gauges use the NMEA 2000 network to send the communication protocol. So you could basically have fuel level gauges all over the vessel, just literally plugging them into the NMEA 2000 network. They're all programmed right off and draw data right off that common network. Any questions on fuel? I mean, I know I spent a fair amount of time, but it seems to be one of the things that, that gets a lot of interest. One of the protocols that, one of the parameters that gets a lot of interest. So DC voltage monitoring is another one, just accuracy, where the sport fishing guys like this, it really has uses in almost any vessel. But one of the nice things about DC voltage monitoring, as I mentioned, we're taking data from so many points along the vessel, around the vessel, that you can synthesize that data and get current discharge rate of the vessel, and the time, the calculation of how much time you have left before you need to start charging batteries, and there's a lot of calculations that can be brought in based on this. AC voltage monitoring is another one. Gensets, being able to see where the voltage is at that point and how much current you're drawing on the network. Electrical switching is gaining popularity very fast, DC and AC switching. If you look at traditional wiring for a DC system, it's pretty basic. We all know it goes, you have a breaker panel, you might have multiple switch points, and there's wire runs that run back and forth between those. And this is a fairly simple diagram. There's 5 or 6 circuits here, and it shows that there's a lot of wiring. But of course, with NMEA 2000 and digital switching, the switch modules are at that point where the displays, the switch panels can be conventional or they can be software. You don't have to, you can eliminate toggle switches and physical switches. We have people that have added DC switching, and they can put remote panels, little digital panels that are, it's a wind display in 1 second, and you flip the screen, and now it becomes your DC switching panel. So there's a lot of flexibility when you start switching AC or DC over NMEA 2000. Basically, it's using the backbone for communication. There's some devices that mount at the point of the power input, and then all of that communication is done over the NMEA 2000 network. Now, wire savings, this is the rear panel, I think this was 8 switches, and this is what replaced it in 8 switches. Because everything's done digitally, they plug into these modules, and it really simplifies wiring. On a refit, that's attractive. It also makes it very easy to add additional switch panels. If they want physical switches, you can add you can add these digital panels anywhere around the vessel. So you could add switches for, a light circuit on either end of a salon or something. It really simplifies DC and AC switching. The way these systems work, they're adaptable to AC or DC. Independent switching of up to 8 circuits. Circuits can be capable of 16. There's actually some systems that are up to 20 amps. They can switch a mix of resisted loads like lights or inductive loads like motors. And you can bridge them. If you needed a 40 amp or a 60 amp circuit, you can bridge multiple circuits to accommodate that. So this particular one from C-Zone, which is probably one of the most popular. Has everybody heard of C-Zone before? Yeah, so C-Zone is a very, very popular brand in DC switching. They were one of the pioneers, and they're kind of leading the way. They're developing products pretty rapidly. But they have 6 20 amp DC circuits. Signals are distributed over NMEA 2000, pretty standard. Multiple circuits, as I mentioned, can be bridged. Their system replaces your standard fuse and circuit breaker. They're actually software selectable with a hardware backup. So they have a physical fuse in the box that if for some reason the electronics failed, you move that fuse over and now everything just becomes an analog circuit. But you can also go in software and say, I want this switch to operate at 10 amps and put a 15 amp fuse in there. So you'd build a circuit capable of 15 amps, you'd software bridge it at 10 amps, and then you sort of have that fail-safe, that redundancy there. So theirs is very unique in that way. They also have DC motor control, a 20 amp DC reversible motor circuit. This is very popular for hatches and things like that. You can set up soft start for motors. So there's a lot of new boat features that you can add to an existing vessel using DC switching. One of the things that I like about it is once all these circuits are on the network, they're all available to do some software synthesization. So one of the things we see popular, as I mentioned here, is opening a hatch. Well, not only is that circuit set up that when you push that button, it opens the hatch, it starts with a soft open, but because the lighting in that hatch area is also set up on NMEA 2000, now when I push that button, the hatch opens slowly, the light comes on. I set it up so when I push that button and close the hatch, 20 seconds afterwards, the light automatically goes off. So there's a lot of uses for this. Once you get that data on this pool, you can really do some unique things with it. You can set up a boarding button where the owner comes to the boat or the captain comes to the boat, hits a remote key fob, and a lighting scheme turns on for them to board. So there's a lot of different areas we can get pretty creative. How am I doing on time, by the way? Good? Okay. Great. So the DC signal interface, it links traditional sensors and switches. What that does, as I mentioned, some people don't want to get rid of those physical switches on the helm. They want to leave them, but they want to have choices on those circuits and how they're controlled, and they want to be able to do that from a multifunction display. So this allows you to use both analog and software switching in the same scheme. You don't have to eliminate the customer's dash and those comfort things that they're used to. There's panels available. C-Zone has them, and I think there's other brands of them out there as well, but they have color touch screens, provide elegant solutions. You can set up schemes. You can set up a whole group of lighting to come on and off at the same time. So there's a lot of things you can do with the software side of this that the owners can get pretty creative on. The switching's also available in Garmin and Simrad MFDs. So almost all, I shouldn't say all because I think there's probably some end of the spectrum that they don't include it in, but almost all of their MFDs have specific software in there to recognize a C-Zone system and allow you to switch on and off right from the multifunction display. And I think we're going to see more integration from other manufacturers as time goes on. So switch state monitoring as well. If the customer doesn't want to go to full DC monitoring, but they do want to monitor some circuits. For instance, be able to see a bilge pump come on and off, or see if a light on an engine room's on. They can do switch state monitoring. It's very simple. It just monitors an existing circuit to tell you whether it's on or off. Just real simple, but it's a nice little add-on, if you will, and very popular with bilge pumps. People want to see the bilge pumps. They might want to get rid of the old idiot lights, but. Switch state monitoring can also be used for high water, vacuum, water and fuel. There's a lot of different parameters that can be monitored with it. Basically any on-off switch, if you will. They monitor, run state monitors an AC or DC circuit to indicate running state. So this could be indicating whether a pump was in the on position or off position. Useful for monitoring bilge pumps, transfer pumps, light circuits, electric motors. Fuel flow monitoring is one that's becoming popular as well because people want very accurate fuel burn information. Most of the systems out there now are actually temperature compensated because as the fuel travels to the engine, when it returns, it's a higher temperature. That adds to the calculation. So they're very, very precise in what they'll tell the system as far as fuel flow. They're monitoring outgoing fuel and what gets returned to the tank and compensating on temperature. Pressure and vacuum monitoring, very popular for an intake. Or air filter to be able to tell without having to go down there and check the little manual one with the engine running to tell what state that air filter's in. Rudder angle sensing, just to know that position and be able to pull it up on an MFD. AIS is becoming popular over NMEA 2000 as well. And there's a lot of black box solutions here that you see. They just simply plug into the network and distribute that data throughout the NMEA 2000 network. Security and alarm is one, as I mentioned early on, just being able to monitor that vessel and be able to send alarm messages out when you're not on the vessel or even when you are. So, the Maritron offers an SMS 100. I mean, it's amazing to me, the people, every boat owner here, every boat owner has a home, and I'd say probably 99% of them have an alarm system in their home. They know the status of their home when they're in it or away from it. But yet, it amazes me how many people have a vessel that's worth 3, 4, 5 times what their house is worth, and they have no idea what's going on with the vessel, and they're hardly ever there. So, one of the things with NMEA 2000, it gives you the ability to monitor that vessel remotely or even on board. But very simple ways, as I mentioned here, the SMS 100, this is a Maritron item, can send email, text alerts if any parameter goes out. We've had sport fishing guys, they leave a cooler full of bait and the freezer fails. They can see that and get a message before they lose all that fish and that bait. And gosh, just the smell of that afterwards isn't going to be pretty. So there's a lot of reasons a smoke detector or carbon monoxide, when they're on the vessel, they'd want to have that information. And it amazes me how few people actually take advantage of that. The other one is data gateways. All this NMEA 2000 does not preclude you from using existing protocols. There's a lot of ways to take ON83 data or other data and convert it to NMEA 2000 messages. An NMEA 0183 to 2000 gateway is one of the most popular. It can actually take data from the NMEA 2000 network and send it over to ON83 and vice versa. There's PC gateways that allow you to take a laptop on board and sort of expand the MFD capabilities very easily. So if you have older electronics on the helm and the customer wants some modern technology, they can view that NMEA 2000 data. Wireless gateways, as I mentioned, sending data off the vessel, which is, I think, becoming very popular. And data logging, I mentioned that early on. This is especially in the commercial and the fleet management. They want to be able to log data so they can hold people accountable, so they can monitor engine parameters over time to see if there's trends that they should be aware of or make maintenance changes. Diagnostics, NMEA 2000, because everything's on one data pool and it's a common format, makes it very easy to diagnose. You can just hook instrumentation up there and view all this data at once and see how it's interacting, instead of multiple systems or proprietary systems where you really don't have an easy way to do that. And then system design software. It's very simple. Maritron offers a free software. There's other companies that have software. There's software out there that makes it very easy to design and troubleshoot these networks, where they actually go through and you build the network on a computer and it'll do all the troubleshooting and everything ahead of time. Saves you a lot of time in the install. And that is a free software. So lastly, you've got this huge information pool. We talked about a lot of parameters that can be measured and a lot of information that can be put on the network. Well, how do you view it? You know, there's a lot of different ways, and I've kind of bridged those or at least brushed those you know, throughout the presentation. But there's popular ways where the traditional digital engine displays, the Cummins guys are going to kill me for saying this, but they're being replaced with something that's a little more modern and you know, matches the look of the helm. Chart plotters or MFDs are probably one of the most common. Almost every plotter out there has the ability to view NMEA 2000 engine data and many other parameters right from the box. Dedicated displays, Maritron Offshore Systems and a few others offer displays that are strictly NMEA 2000. Vessel computers, there's a lot of different brands. KEP has a monitoring system, Maritron offers a monitoring system. It can be either dedicated hardware with the software preloaded, or it can be your PC or your touchscreen connected to a PC that has that in it. So it's very customizable. What the end user sees, that GUI interface on the dash, can be very customizable to that vessel and what they want to see at that time. PC software is very popular because it's fairly inexpensive, it's very customizable, and it's very expandable. Wireless devices are gaining popularity. As I mentioned earlier, sailboats. That's a common one with a sailboat that wants to see that diesel information without adding a bunch of gauges or tying up, you know, their MFD. They can use an iPad for the short amount of time that they're tooling around with the diesel running. iPad and Android apps are coming into their own as well. Now, they're not really daylight viewable, but there's a lot of reasons that they're being used on vessels, especially, you know, in closed cockpits. Tablet integration, this particular one here, the customer wanted the MFDs with as much real estate as possible, and then there's 2 iPads that cover engine data. And that's it. Thanks. Are there any questions on any of that? Well, thanks for your time.
Questions? Wait, there must be.
Sorry?
Yes, over here.
Got that light right in my eye.
Is any of the information transmitted through Bluetooth?
You're going to have to repeat that question again.
There are gateways. The question was, is any of the transmission, the data transmitted via Bluetooth? And that's a great question, and I should have covered that in there. I mentioned gateways. There's a lot of different ways to get data off of that network, and one of them is Bluetooth. The problem with Bluetooth, of course, is it's short range, 30, 40, 60 feet. In most cases, vessels have bulkheads and stuff. So Wi-Fi seems to be the more popular choice, but yes, a lot of the MFDs have built-in Bluetooth capability for short-range communication, and really, I think that's useful for expanding. They want to leave the chart plotter showing, but they want to show fuel levels at the same time. So for short-range communication, yes, there's gateways available, and some MFDs already have Bluetooth capability built in. Wi-Fi probably is the more popular choice, though. Any other questions? Yes, sir. Sorry.
Is there any data security built in the protocol?
Data security as far as, help me with a little bit with what type of security, like?
With being able to take the information that's on the boat, off the boat,
Microphone.
Well, the nice thing about that's an excellent question, because a lot of fleet owners, you know, even captains, I mentioned that we had a customer in Charleston that has a fleet of tugs and he's had problems and he's monitoring it, but he doesn't have anybody else access. That security is in that Wi-Fi protocol. So unless they know how to access the data on the boat, getting the data off the boat can be very secure as whatever they choose for that wireless protocol getting it out. So yes, there is security available. Most of it falls on the communication side on the Wi-Fi, not the NMEA 2000 side. And you had a question, yes?
Quick question. Is there, I guess, transducers, transponders, whatever, for vacuum on fuel filters?
Yes.
Can you repeat that, Peter?
Okay, yeah, so he asked, is there a protocol or a product for vacuum on fuel, you said on fuel? Fuel filters, yes. One of the things nice about NMEA 2000 is almost all of these things are configurable. So as I mentioned, there is vacuum sensors. They're used on intake, they're used on fuel. You can program what you want for ranges. The vacuum transducer itself, just like a conventional one, would have multiple ranges available. So you'd buy the range that you needed for that application. And when it went on the NMEA 2000 network, you would label it as, you know, fuel vacuum or intake vacuum. So yes, there's sensors available to do that. It's simple custom labeling in the software, so that way there, when that data is out on the network, the devices know how to read it and how to display it. It's a good question, though.
One more question right here.
For traditional boats, like an engine display, of course, we know you can display the information digitally, you know, on your fish finder or whatever, you know. But do they have analog looking gauges as well, so that it look like a traditional analog gauge, however, it would be a NMEA connection?
Excellent. I should have had everybody help me with my presentation, because that's a really good point, is that we have a lot of people that want the NMEA 2000 protocol, but they don't want to give up that old look. Now, on a conversion, as I mentioned, you can convert that data coming to that analog to NMEA 2000. But if it's a newer build and they've gone all NMEA 2000, there's companies like VDO. VDO has a system called Aqualink that uses NMEA 2000 to power their analog looking gauges. Now, you're a little limited on the options available. In other words, there's only so many styles. But I believe that Faria also has some that can read NMEA 2000. And I believe that they have some that are customizable. They can read different protocols, J1939 directly. But I know for a fact that VDO has a system called Aqualink, and they're more traditional gauge. They'll read off the NMEA 2000 network. There's also drivers, offshore systems. I don't mean to take so much time up, but there's this driver from offshore systems that will allow you to drive each gauge off the NMEA 2000 network. And it's a simple little device that plugs into a T. You tell it oil pressure, and it pulls that PGN, that information off that network, and sends it to an oil pressure gauge. So essentially, it's NMEA 2000 to analog. In that case, you could use any sender from any brand as long as it was compatible with that resistive output.
What's the name of that company again?
Offshore systems. They call them gauge drivers, NMEA 2000 gauge drivers. I'll give you a card. I'll get you some more information on that.
Peter, thank you very much.
Thank you.
Great presentation. Peter, take that. Thanks.